Hello, let's talk about significant figures. Significant figures are, you're going to show your values that you measured, and it has to reflect the precision of your measurement. So these are 4 rules to count your significant figures. So first, all non-zero digits are significant, meaning if it's any numbers, it all has to count other than zeros. So 1.234, none of them are zero, so there's 4 significant figures. 1.2, they're not zero, all 2 counts as sig figs. Number 2 rule, all zeros between non-zero digits are significant. So if you have a zero that's sandwiched between the 2 different numbers, then it has to count. So 1,207, 0 is between 2 and 7, so that has 4 sig figs. 120.007, all of those 3 zeros are sandwiched between 2 and 7. Therefore, all of them counts. 1, 2, 3, 4, 5, 6 has 6 sig figs. Number 3, zeros to the left of the first non-zero are not significant. So you have number 3, 2 here, but the 0 before that, anything, even if it's in the decimal, it doesn't count because it's only going to show you the order of magnitude, not the actual precision. 0.03, same thing, before the 3, all of those zeros won't count. It's not really sandwiched. Number 4, trailing zeros for a whole number that ends with a decimal point are significant. So you add this 0 because it has a meaning, okay, not for the order of magnitude. Therefore, all 3 counts 3 sig figs. Here, all of that first 0 doesn't count, so we only have to worry about this trailing 0, but that trailing 0 is after the decimal, therefore it counts. It is 1, 2, 3, 4, 5, okay? Let's look at some examples here. 0.00682, those 3, I can't highlight that. Those 3 won't count. Only 6, 8, and 2 counts for sig fig. Therefore, that is 3 significant figures. And how do we change that to a scientific notation? We use just where the number starts. That is non-zero, so starting from 6, 8, 2. And then we count the decimal points. Therefore, it'll be 1, 2, 3, orders of magnitude smaller than 1. 1.0720 is sandwiched between 1 and 7. They all count 1, 2, 3, 4. 300, this trailing 0 is just to show you the order of magnitude. It is not behind the decimal trailing. Therefore, only 3 counts as 1. So when we write the sig fig, only that 3 counts, and that 2 is the order of magnitude. So we do not write this 300 as 3.00, 10 to the 2, okay? It has only one sig fig. But if you have a decimal here, then it means these 2 numbers actually count. That means there's 3 sig figs. And if you're writing a scientific notation, you have to write it with 3 significant figures. These behind the numbers only show the order of magnitude, so you don't have to worry about the significant figures. Its sig figs are what's in front of that order of magnitude. So here, there's a decimal. Any 0 trailing behind the decimal counts, so that one counts. So 1, 2, 3, 4 significant figures, and you have to write all of the zeros to show all the sig figs when you're writing the scientific notation. So here, let's try. Let me give the answers really quick. 4,500, the 2 zeros don't count because there's no decimal behind it. There's 2. There's a decimal point here, therefore those 2 zeros will count. Therefore, it's going to be 4. Before the number non-zero numbers, those 3 zeros don't count. Therefore, it is just 2. Again, sandwiched between the 2 numbers, 0 counts. Trailing behind it, decimal that does count. Therefore, that's also 4 sig figs. All right, let's do how to calculate it. If you have addition or if you have a subtraction, then it's going to go by the first doubtful digit. Okay, that means find a smaller decimal number of decimal. Okay, so let me give you an example here. If you're going to add these 3 numbers, okay, the smallest decimal number is the 2.02, this one. Those are larger decimal numbers. So we go by the smallest number right there. So you do the math, 4.7832, 1.234, 2.02, add them all up. You find the number answer, and then you round it to the correct decimal point. 8.03, the next number is 7, so you round it to 8.04. Subtracting is the same, 1.0236 minus that big number, the smallest decimal point will be over here. So we're going to round it there after we calculate. So after you calculate, you round it to this 1, 2, 3, 4th, 10 to the minus 4 digit right there. 2, we round it to 0.0509, okay? The multiplication rule is different. So we go here, the least accurately known number so that it means smallest number of sig figs. So you count how many each number has, the sig fig it is, and then you find the smallest one. So I'm going to multiply these two numbers. The top number, 2.8723, has 1, 2, 3, 4, 5 sig figs. 1.6 has 2 sig figs. So therefore, we're going to use 2 sig figs for the final rounding answer. 2 sig fig, so you round 4.5. 9 is bigger than 5, 4.6. Division is the same. Find 3 sig figs, 5 sig figs, and then you choose the 3. So at the end, you have to round it so that it has 3 sig figs. All right, here we go. Let's try these questions. Do the math first, and then because they're all additions, you're going to find the least decimal point. So that will be 550.55 right there. It'll make more sense if you do it vertically. So that will be 34.90, and then you have 550. That's the last digit. This is the last digit. And that's the last digit. The answer was 5087.9. Let's match that decimal right there. So we have to round it to this digit right there, okay? Because the tens is the least accurate, a precise number that was given. Therefore, the answer is 5090. There we go. Oops. Therefore, 5090. We do that right there. Give the answer to the correct number of sig figs for the bottom. So you do the math again, 1.367. And then the least number that's given there, known digit here is 7. This one is 4. So we have to round it to that number 4, where that is. So 0.01 digit. So if you do the math, the answer is 0.027. Therefore, we have to round it to this digit right here. So the answer is 0.03. That's the final answer. Give the answer to the correct number of sig figs for multiplication. Count the sig figs, 2. Count the sig figs, 4. Therefore, 2 is smaller. So our final answer will be 2 sig fig. So we will round it to 7.4. 2 sig figs. Let's do the next one. This division, we count the sig figs, has 4. 0.010, lots of zeros, right? These two don't count. This 0 does count. Therefore, sig fig is 1 and 0, 2. Okay? So after we do the division, we should have our answers and 2 sig figs. So the answer for that is going to be 630500. So to have only 2 sig figs, we will round it to 63 and 4 zeros. We don't want to write it like that. We're going to have it in 6.3 times 10 to the power 1, 2, 3, 4, 5. So power 5. So superscript 5. All right. Make sure you do some more practices after you go to the more resource or the worksheets we have.